Okay, so in this video, we're going to talk about conservation of momentum and specifically in elastic collisions, just elastic collisions. So first of all, conservation of momentum, the technical definition is the total amount of momentum within a system remains constant. Momentum is neither created nor destroyed, only changed through actions of forces. It's very similar to the law of conservation of matter. But another way of looking at it is that when you have two or more objects colliding, the combined momentum of the objects before the collision is going to be equal to the combined momentum of the objects after the collision. So however much momentum there is between the objects all together before the collision, it may change in terms of which object has more momentum than the other. The direction of the momentum may even change, but as a whole, the total amount of momentum will be the same. So if one object loses momentum, then the second object is actually going to end up gaining that momentum. We're going to focus on elastic collisions. In a perfectly elastic collision, which is not really what happens in the real world, there is going to be some energy lost to sound, to heat in a real world collision, but we're going to look at it in a perfect world. When you have the two objects, they're going to either completely bounce off of each other, like in scenario B here, where they're the same size and they're coming at each other with the same amount of force. And so when they collide, they're actually going to swap their momentums and bounce right off of each other. The other scenario that could happen is some or all of the momentum can be transferred from one object to another. So in this example, in C here, the orange ball is actually giving some of its momentum to the white. So it's losing some, but it's still going to end up moving. So it doesn't lose all of its momentum, but it does lose some of its momentum. Versus in scenario A here, where because the first one is sitting still and is not moving at all, when they collide, the first object gives all of its momentum to the second. Now this equation looks giant and probably slightly terrifying, but it's actually really simple. If we remember that momentum is P equals mv, then what we have here in reality, let me just get my pen here, is we have the starting momentum of object 1, so PO1, plus the starting momentum of object 2. And it doesn't matter if you put the letter or the number first. So I could, down here I put 20 or 20. If you put O2, it doesn't really make a difference. But those starting momentums are what is going to equal the final momentum of object 1. So PF1, oops, make that an F, plus the final momentum of object 2. Now, depending upon the information that you're given, you'll either use the expanded version of this equation or the simplified version of the equation. Okay. So let's look at this example. We have bumper car 1 has a mass of 300 kilograms and is moving with a velocity of 10 meters per second. This bumper car hits bumper car with a mass of 125 kilograms that is sitting still. After the collision, bumper car 1 moves with a velocity of 4.12 meters per second. What is the velocity of bumper car 2? So first thing you should always do is write down the information that you know. When you're looking at, and as we get into these larger word problems, you're going to really want to make sure you list all of the variables, because one, it's going to help you know what equation you want to use, but then also it just helps keep things clear, especially when you have multiple objects things happening with multiple objects. So I have the mass of object 1, I have the initial velocity, and I have the final velocity. I have the mass of bumper car 2 It says that bumper car 2 was originally at rest or sitting still, so that meant the original velocity was 0. So as we can see, there's only one variable that I don't know. So I'm going to start filling in those variables. So I have 300 times 10 plus 125 times 0, which is essentially 0, equals 300 times 4.12 plus 125 times my final velocity. So my goal is to solve this equation for V2F. Once I simplify combine all like terms, I have 3,000 equals 1,236 plus 125 times the final velocity. In order to get closer to solving for that, I'm going to subtract 1236 from both sides. So I get 1764 equals 125. And then finally, I will divide both sides by 125. So the final velocity will be 14.11 meters per second. All right, so go ahead and pause the video, take a second, see if you can solve this one by yourself. Okay, so again, we're going to look at this. Now we need to remember that velocity is vector, therefore momentum is vector. So we have two objects that are rolled towards each other. Object A is 3 kilograms moving to the left with a velocity of 8 meters per second. Object B is 5 kilograms moving to the right at 12 meters per second. They collide, bounce off of each other. Object B has a velocity of 2 meters per second to the left, and trying to find the final velocity of object A. Now, since it's moving to the left, I have my final velocity as negative 8 meters per second. And since the second object has a final velocity of 2 meters per second to the left, I'm going to make that negative 2. Again, I'm going to plug all of these into my equation. So I have 3 times negative 8 plus 5 times 12 equals 3 times the velocity, final velocity of object 1 plus 5 times negative 2. Simplify, get 36 equals 3 times the final velocity plus negative 10, or you could just put it as minus 10. So I'm going to add 10 to both sides. So 46 equals 3 times the final velocity. Divide both sides by 3, and you get 15.33 meters per second. Okay, now we're going to take this a little bit further. In this case, we have, we're looking at a 1,200 kilogram car traveling 7 meters per second, and this collides with the back of a 2,500 kilogram truck traveling 3 meters per second with a force of 5,750 newtons. And the collision is going to last 0.5 seconds. Now we're going to be taking all of this, and we have to remember that we have multiple equations here. We don't want to forget that we have our impulse is force times time, and that we have that momentum equation, the original momentum of object 1 plus the original momentum of object 2. I'm going to write the simplified version for the sake of simplicity here, is going to equal the final momentum of object 1 plus, a little bit better, the final momentum of object 2. Okay, so I'm going to go ahead and take this information here. I'm going to figure out what my initial momentums are. So I have here 1,200. Actually, let me see if I can switch this to typing here, just to make it a little bit. Nope, it doesn't have that. Okay, we're going to just keep going here. That's kind of messy. There we go. Okay, so I have 1,200 times 7, because that's its original velocity, plus we have 2,500 times 3. So if I'm going to simplify that, this is going to be 8,400 plus 7,500. Okay. All right. So that is going to be added together to give me what my total momentum is. So my total momentum here is going to be 8,400 plus 7,500. So my total momentum is 15,900. So that is this portion of the equation. So that tells me that this portion is also going to have to equal 15,900. But I want to know how their momentums are going to change after they collide. So the next thing I have to figure out is I need to figure out what is the impulse of this situation. Well, I have impulse is force times time. So I'm going to have 5,750 times the amount of time, which is 0.5. So I get a momentum, or sorry, an impulse of 2,875. Okay, that is my impulse. That means that these two momentums are going to change by 2,875 kilogram meters per second. So we have to think about in this scenario, who is going to lose momentum and who is going to gain momentum. And the best part, or one of the easiest ways to do that, is to think about what is happening in the real world. Well, if this car hits that car from behind, it's going to push that car forward. Therefore, it's going to lose some of its momentum. Another thing to think about is who has the bigger momentum. The car has more momentum than the truck. So it's going to be the loser in this situation. It's going to lose momentum, and the truck is going to gain momentum. So what I'm going to do here then is I'm going to say, okay, let's see if I can change this color really quickly. Okay. I'm going to do 8,400 minus my impulse, which is 2,875. And the truck is going to have 7,500 plus 2,875, because whatever one loses, the other gains. 2,875. So that means that my new car momentum is going to be 2,875. It's going to be 5,525. And 25. Whereas my truck's new momentum is going to be 10,375. And then I can double check and add those two together and make sure they still equal that total momentum. So that gives me the original momentum, the impulse, the final momentums, and then if I wanted to calculate the final velocities, what I would do, I would simply go ahead and I would take the momentum that they have. So I have 10,375 and divide that by their mass. So in this case, divide that by 2,500. And so I would get the final velocity of my truck. Sorry, the writing is getting a little bit messy here. Would be